Hello students, welcome to this session. In this session, we are going to discuss about Ohm's law and Kirchhoff voltage law with few numericals of previous question papers. So let us move on into session. So Ohm's law, we have already seen this statement, but once again we are going to see here for calculating a numerical. So Ohm's law, as we know, it gives the relationship between voltage and current in a conductor. So the Ohm's law states that at constant temperature, the current flowing through a conductor is directly proportional to the voltage across its terminals. And to remove this proportionality, we have a proportionality constant that is represented as R, which is nothing but resistance. And the formula for calculating voltage, current, and resistance is nothing but V equal to I into R. So, with this information, let us draw the characteristics of voltage. Let us draw the characteristics of resistor between voltage and current. So this was the question asked in 2017 BW question paper. So on the left side, you can see a circuit where a resistor is connected to a voltage source V. Okay, so here what we are going to do is by keeping the resistance value as constant and by varying the value of voltage, we are going to see whether Ohm's law is verified or not. Okay, so let me take the value of resistor as 10 ohms for simple calculations, and I am going to vary the voltage between 1 to 20, 1 to 20 volts with a variation of step 2. Okay, so let us calculate a current with a variation of 2 of voltages. Okay, so I'm going to draw a table between voltage and current, keeping the resistance value as constant so that we can get the VI characteristics of a resistor. So here voltage and current are formed into a table. So let us see. Let me take the voltage as 1 volt initially. So 1 volt, and we know that the formula to calculate the value of voltage if we know current and resistor is like this. So in this question we know the value of voltage and we know the value of resistor. So let us find the value of current by using this formula I equal to V by R, where R value is 10 ohms, which is a fixed value. Okay, so by varying the voltage V, we are going to find out the value of current I. So V, it is 1 volt right now. So 1 divided by 10, it is nothing but 0.1 amperes. So it is 0.1 amperes. Similarly, next value, let me take it as 2. So it is nothing but 2 divided by 10. So it will be 0.2 amperes. So it is 0.2 amperes. Similarly, if I take it as 4 volts, then it will be 0.4 amperes. So if I take it as 6 volts, then it will be 0.6 amperes. If I take it as 8 volts, it is 0.8. Similarly, if I take it as 12 volts, it will be 1.2 amperes. If I take it as 20 volts, it will be 2.0 amperes. So what we are going observing here is that as the voltage is increasing from 1 to 20, there is an equal increment in the current, or there is a linear increment in the current from smaller value to higher value. That means if we plot a graph between voltage and current, where voltage is taken on the y-axis and current is taken on the x-axis, we'll be getting a linear graph. And here we can observe that the slope of this graph is always equal to the value of the resistance what we have taken. Okay, so if you are taking another value of resistor, for example 20 ohm, with the same values of voltages, you may get the currents as 1 by, first current will be I equal to 1 by 20. equal to 1 by 20. So it will be 0.05. 0.05. Similarly, it will be 0.1. It will be 0.2. It will be 0.3, 0.4, and so on. It will be 0.6, and this will be 1. Okay, so here you can observe that as the resistance is increased, the current is getting decreased. So depending on the values of voltages and currents, we can draw a graph which will be always a linear fashion, and the slope of this graph will be giving you the resistance whose value is constant throughout the values of voltages and currents. So let us see a problem related to Ohm's law. This was a question given in BEE exam in May 2018 for 3 marks. So the question is, the essential component of a toaster is an electrical element that converts electrical energy to heat energy. So how much current is drawn by a toaster with resistance 15 ohms at 110 volts? 15 ohms at 110 volts. So we know that the element which converts electrical energy into heat energy, that is, heat is only dissipated in a passive element which is nothing but a resistor. So we have to draw a circuit so that we can label all the given information. So this is a voltage source of 110 volts, and this is a resistor whose value is 15 ohms. Okay, so he's asking how much value of current is being drawn by the toaster whose value is 15 ohms. So we know that V is equals to I into R. So from this formula you can find the value of current I as V by R. Right. So what is V here? It is 110, and what is R? It is 15. So the value of this current is 7.33 amperes. So 7.33 amperes is being flown through the circuit to for a toaster whose voltage is 110 and whose resistor is given as 15 ohms. Moving on to next problem. So this is a problem of same May 2018 for 3 marks. The question is 5 2-volt cells each having an internal resistance of 0.2 ohms are connected in series to a load of resistance 14 ohms. Find the current flowing in the circuit. So first understand what he is asking and draw the circuit depending on the given values. Okay. So here it is given that 5 2-volt cells having an internal resistance of 0.2 are connected to a load of 14 ohms, and that is in series. Right. So 5, what is this cell? Cell is nothing but actually it is a cell. This is how a cell is represented. This is the value of voltage and this is the value of internal resistance. Okay. So combination of n number of cells is known as a battery. Combination of n number of cells is known as a battery. Okay, battery, we usually see it has positive and negative terminal, right? So combination of n number of cells is known as battery. So here it is given as 5 2-volt cell having an internal. So let us draw 5 2-volt cells with an internal resistance. So there are 5 cells with internal resistance. This is 4. Let me draw here. It is 5. Right. So 1, 2, 3, 4, 5. This one is one cell. This one is one cell. This is one cell. This is another cell. This is one cell. So this combination of this total is known as a battery, and battery will have same internal resistance and voltage. So what is this voltage? It is 2 volts. What is this resistance? What is this resistance? It is given as 0.2 ohms. So 2 volts, 0.2 ohm. 2 volts, 0.2 ohm. 2 volts, 0.2 ohm. 2 volts, 0.2 ohm. So as they are connected in series, we know that for calculating series resistance, we use a formula, that is R1 plus R2 plus R3 plus R4 plus R5. Similarly, the voltages V equivalent equal to V1 plus V2 plus V3 plus V4 plus V5. Right. So there are 5. So I have taken it as 5. So it is nothing but, as there are of same values, R equivalent is N into same value of resistor, that is 5 into 0.2, that is nothing but 1 ohm. Similarly, V equivalent equal to 5 into 2, that is 10 volts. So now this 10 volts with an internal resistance of 1 ohm is connected to a load of 14 ohms. So draw the final circuit. So let me draw like this. A voltage source with an internal resistance of 1 ohm is connected to a load of load of 14 ohms. This is 14 ohms, this is 1 ohm, and this is 10 volts. So now as these two resistors are in series is nothing but a interconnection of two resistance at one common point. So here it is only one common point. So now the circuit can be redrawn as like this. I'm just rotating the circuit. Okay, so this is 10 volts and this is 15 ohms because R1 plus R2 series. Right. So the current flowing in the circuit is being asked. So what is the formula? I equal to V by R. So what is V here? It is 10. What is R here? It is 15. So it is nothing but 2 by 3, which is equal to 0.666 amperes. Okay, so have you understood how we have done? Here 5 cells of 2 volts and internal resistance of 0.2 are connected in series with the load. So as they are connected in series, we have calculated the equivalent voltage and equivalent internal resistance of the battery, right, of a cell. Right. Then we have connected it into a load, and then we are finding the value of current by using this form. Okay. So this is how you have to solve numerical depending on the question given. You have to first analyze the circuit, draw the circuit, then find out the required parameters being asked. So next, moving on to Kirchhoff's voltage law. So this was a question in BWE in 2016, 17, 19 and 2020 also. So it is a very useful law for electrical circuit analysis. So in 1845, a German physicist, Gustav Kirchhoff, developed a pair of or set of rules or laws which deals with conservation of energy and charge within electrical circuit. So this Kirchhoff has two laws. One is voltage law and the other one is current law. So here I am going to discuss about this voltage law. So Kirchhoff voltage law is the second law of his fundamental laws we can use for circuit analysis. His voltage law states that for a closed loop series path, the algebraic sum of voltage drop across each element is equal to the source voltage, or the algebraic sum of all the voltages around any closed loop in a circuit is equal to 0. So this law deals with law of conservation of energy. So how it works we are going to see in the problem. So there we have find a term known as series. So let me make you clear what do you mean by series circuit. So when you are taking two resistors, this is your resistor 1 R1 and this is your resistor 2 R2. Okay, so these two resistors are connected in such a fashion that there is a common point in between two of them. There is, or they are connected to one common point. This is your R1 and this is your R2, and to this combination there is a voltage source applied across its terminals. There is a voltage source applied across its terminal. So this fashion of connection of resistors with one common point is known as series circuit. Okay, so let us take this as voltage V and let us find the currents in the circuit. Let us find the currents in the circuit. The basic law we know that is V equal to IR. This is from Ohm's law. Okay. So if you observe here, let Vt is the total voltage of the circuit and It is the total current of the circuit. So to find the value of total resistance or total resistance, you can write it as Vt equal to It into R. Okay, you can also see that as the current flows through resistor 1, there will be an voltage drop occurred across this resistor. There will be a voltage drop occurred in this resistor which is represented as V1, and as the current flows through R2, there will be a resistor drop across this resistor which is measured as V2. So we know that in the circuit according to KVL, the algebraic sum of the voltage drop across each element should give rise to your source voltage. So the algebraic sum of voltage drop across each element, that is V1 plus V2, should be equal to your total voltage. And if you observe here, the formula for V1 is nothing but, as a current is flowing here, is total current IT, and here also in resistor 2 the same current is flowing so that it can reach its negative terminal. So IT into R1 is your V1 plus IT into R2 is your V2, and we also know that VT is nothing but IT into R equivalent, that is total current into R equivalent. So from this we can see that there is a common current flowing in the circuit. So R equivalent is nothing but R1 plus R2. This is the formula for resistors when they are connected in series. This is the formula for resistors when they are connected in series. So if you know R equivalent and if you know the total current flowing through the circuit, you can find the voltage. Or if you know total current and if you know R1 and R2s, you can find out the values of V1 and V2. And if you add it up, you will be getting your total voltage. And here one more thing we need to know is about voltage divider rule. Voltage divider rule. So what this voltage divider rule says. So for a series circuit, as you observe, this total voltage is being divided into two parts. Like there are two resistors, so it is being divided into two parts. If there are three resistors, then it will be divided into three parts. So to find out the voltage drop across each resistor, to know the voltage drop across each resistor, you can either use this method or you can directly find it out by using the formula given. So the voltage drop across resistor 1 V1 is equals to total voltage into the resistor for which we are finding the voltage drop divided by sum of all the resistors. Sum of all the resistors. So if you observe here, this Vt by R1 plus R2, this Vt by R1 plus R2 is nothing but Vt into R1 divided by R equivalent. So what is Vt by R equivalent? It is nothing but It, that is total current. So it is nothing but total current into R1. So it will be the same formula. Similarly, what is V2? V2 is total voltage into R2 divided by R1 plus R2. So it is nothing but total current into R2. So either you can use this formula or you can use this formula to find the voltage drops across resistors R1, R2. And depending on the resistor value, the R equivalent, that is equivalent resistance of the circuit, will be vary. As if there are 3 resistor, it will be R1 plus R2 plus R3. If there are 4 resistor, then it will be R1 plus R2 plus R3 plus R4, and so on if there are n resistors. So this you need to remember for series circuit. So moving on to next, here we are going to solve two problems of same type. Okay, so by using, by applying Kirchhoff's voltage law. Okay, so if you see, I am starting with this, and let be this second problem. Okay, so let me start with this. So let us first solve the circuit and then later on we'll do it here. Okay, so here as you can see that there are two resistors which are connected in series. Why I am saying they are connected in series? Because they are only having one common point, right? So they are having one common point, so they are connected in series and to a voltage source of 20 volts. To a voltage source of 20 volts. So here we are going to check whether KVL is applied or verified or not, right? So, according to the statement of Kirchhoff voltage law, the algebraic sum of all voltages in the loop. Now, what is loop? Loop is nothing but a closed path. It is a closed path starting from one point and reaching that point. It is known as a loop. Okay, so it is a closed path. So, the algebraic sum of voltages in a closed path should be equal to 0. The algebraic sum of voltage in a closed path is equals to 0. Is equals to 0. So by using this statement, we are going to write the equation for the given circuit, which is nothing but a loop or a closed path. Okay, so let me first define the direction of current. Let me first define the direction of current. So as we know that, whenever we apply a voltage source, a current starts flowing. So let the direction of the current be like this. Okay, let the direction of current be like this. So again, next here it is flowing I, then again here it is I. Like this the current will be flowing in the circuit, right? Like this the current will be flowing in the circuit. So how we are going to write the equation for this closed path? We are going to write the equation for this closed path as whatever the terminal is coming in contact with the current at the initial point. Like for example, to write this equation, I am starting with the terminals here for V1. Okay, so it is plus V1 because the terminal which is first reached by this current in the path is plus. So plus V1. Next it is plus V2. Next here it is minus 20 equal to 0. minus 20 equal to 0. I am repeating it again. Whatever the terminal which is first reached by the path of the current is taken as the sign for writing the value of voltage. Okay, so it is plus, which is the first path reaching. So plus V1 plus V2 minus 20 equal to 0. Right. Now what is V? V1 is nothing but I into R1 or I1 into R1, and V2 is nothing but I2 into R2. Now what is this I1 and I2? I1 is equals to I2 equal to I because the same current is flowing through this resistance of 2 ohms and this resistance of 3 ohms. Okay, so let this be R1 and this be R2. Okay, so same current is flowing from resistance R1 and same current is flowing from resistance R2. Right. So write down the value of or let me just write this as equation here. So it is I1 R1 plus I2 R2 minus 20 equal to 0. As these are same, so I into R1 plus I into R2 minus 20 equal to 0. Now what is I? We need to find out. We know the value of R1 as 2. So it is 2I plus 3I minus 20 equal to 0. From this, if I take I as common, it is nothing but 5. 2 plus 3, 5 minus 20 equal to 0. That means I equal to 20 divided by 5. That is 4 amps. 4 amps. Now, now find out V1 and V2. So V1 nothing but I into R1, that is 4 into 2, which is 8 volts. Similarly, V2 is equals to I into R2, which is equals to 4 into 3, which is equals to 12 volts. Now place this V1 and V2 values in this equation. To so that we can see whether it is equal to 0 or not. So what is V1? V1 is 8 plus 12 minus 20 equal to 0. That means 0. So it is how where KVL is verified. That means the algebraic sum of the voltages in a closed path equal to 0, or the algebraic sum of the voltage drop across each element is equals to the source, right, is equal to source voltage. That is 8 plus 12 is nothing but 20. So what is the value of source voltage? It is 20. So both these statements are verified here. Now moving on to the next problem, that is second problem. Here you can observe that the voltage for V2, it is minus and plus. Minus and plus. By using the same principle, we are going to write the equation. We are going to write the equation and check whether what is the difference between these two circuits depending on the signs. Okay, so what is the equation? It is nothing but plus V1. Now here the first terminal which is touched by I in its path is minus. So minus V. So plus V1 minus V2 minus 20 equal to 0. Minus 20 equal to 0. Plus V1 minus V2 minus 20 equal to 0. Now what is V1? V1 is I into R1, that is I into 2, it is 2I. Similarly, what is V2? V2 is minus I into R2. Minus I into 3, so it is minus 3I. So why we have taken minus? Why we have taken minus? So here one point you need to remember is that the current should always the current should always flow from positive to negative terminal. Positive to negative terminal for passive elements, that is resistive elements. Okay, for passive elements. But here, as you observe, the current is entering at a minus and leaving at plus. The current is entering at minus and leaving at plus. That means it is flowing from negative to positive. So the direction of current for this resistor is in opposite to the direction of current what we have taken. That means it is like this. Okay, it should be like this, but it is in the reverse manner. So that's the reason here negative of I is being taken. Negative of I is being taken. Okay, so let us substitute that here and find out the value of current and then find out what are the values of voltages, right? So that is V1 minus V2 minus 20 equal to 0. Now V1 is 2I minus of minus 3I minus 20 equal to 0. That is 2I plus 3I minus 20 equal to 0. That will give you I is equals to 4 amperes. Same as previous problem. Now what is V1? V1 is equals to 2 into V1 equal to 2 into 4, that is 8 volts, and V2 is equals to, what is V2 here? Minus 3 into I, that is minus 3 into 4, that will equal to minus 12 volts. Okay, so substituting that in this equation and checking whether KVL is verified or not. Checking whether KVL is verified or not. So it will be 8 minus of minus of minus 12 because it is minus V2. So minus of what is V2? V2 is minus 12. Minus 20 equal to 0. So 8 plus 12 is 20. 20 minus 20 is 0. So it is verified. So the thing here you need to note is that the current should flow from positive to negative. Should flow from positive to negative, as there is a direction reverse for this circuit. So we are going to take it as minus or negative sign for the current, and we are finding out the equation, and we are writing the equation, and we are finding out that whether KVL is verified or not. So you need to be careful of such type of problems. Okay, so that the points which you have to note is that for series circuit, first point, the resistors have one common point. Resistors have one common point between. Second point is the current flowing in all the resistors is same. In all the resistors is same. Similarly, the voltage gets divided among the resistors depending on their resistance, depending on the value of resistance, value of resistance. And one more thing what you need to observe is that the equivalent resistance will be always greater than, greater or more than the highest value of resistance. The highest value of resistance given in the circuit. Given in the circuit. And if there are same resistance, if there are same value of resistance, same value of resistance, then R equivalent equal to n times of R. R equivalent equal to n times of R. That means if the resistance R, for example, R value is 1 ohm and there are two resistance, number of resistance are 2. Two resistance of 1 ohm, then R equivalent equal to either 1 plus 1 which is 2 or 2 into 1 which is 2. Okay, so if there are same value of resistor, the value of equivalent resistance is n times of R. Okay, so in next session we are going to learn about Kirchhoff's current law. Thank you.